Okay, so our notes gives us a sine, sum, and difference identity. And we've been dealing with identities, and we know identities to be true if we can verify them. So what we're going to do now is we'll use the angle 105, the sine of 105, and we are going to verify if this identity is indeed true using the angle 105, and we'll take the two angles 45 plus 60, which we know adds to 105. If this identity is indeed true, we should get approximately 0.97. So let's do some work here, and let's use the formula for the angle sum and difference identity for sine. Now, if we notice, we are adding these two angles, so that means that we're going to be focused on the sum identity for sine, which says that the sine of angle A plus the sine of angle B is equal to the sine of A times the cosine of B plus the cosine of A times the sine of B. All right, so let's go ahead and work that out, and we are going to figure this out. So let's just plug in. We're going to substitute for A and B in that formula, 45 plus 60. So 45 would obviously be A, 60 is our angle B. So we're going to say this has to be equal to the sine of 45 times the cosine of 60 plus the cosine of 45 times the sine of 60. Now, what we're not going to do is use our calculator at this moment, because we know the angles 45 and 60 are on the unit circle. 45 is pi over 4, 60 is pi over 3. So we know the sine and cosine values of those angles. So let's just take a second. Let's reflect and think about what the sine and cosine values are of those particular angles. Okay, I'm so proud of you if you pull those sine and cosine values from your memory. But recall on the unit circle that the terminal points tell you the sine and cosine value, that the x terminal point at that angle is the cosine of that angle, and the y is the sine at that angle. So we know that the sine of 60 degrees is going to be radical 3 over 2. The cosine is 1/2, and the sine of 45 is radical 2 over 2, and the cosine is radical 2 over 2. So let's go ahead and substitute those values into our equation. We have the sine of 45 plus 60 is equal to the sine of 45, which we know from the values is radical 2 over 2, times 60, the cosine of 60, well, the cosine of 60, which we know from the values, is 1/2, plus the cosine of 45. Well, we know the cosine of 45 is going to be radical 2 over 2 times the sine of 60. Well, we know the sine of 60 is radical 3 over 2. Let's go ahead and simplify this expression. When we simplify radicals, remember we can multiply them, right? Radical to radical. And with fractions, remember we're multiplying across. So let's simplify this expression. First, I'm going to multiply the first terms. Radical 2 times the 1 is just still going to be radical 2. And the denominator 2 times 2 is going to be 4. So I have a radical 2 over 4 plus over here, radical 2 times radical 3. Remember, because they're both radicals, we can multiply them. So that's going to be radical 6. And in the denominator, 2 times 2 is 4. Now let's add these two expressions together. Let's see, the sine of 45 plus 60. And guys, we are not using a calculator. This is meant to be exact value. So if I add these expressions together, remember with adding fractions, we got to have a common denominator. So we already have one. It is 4. So this is just radical 2 plus radical 6 over 4. Now, does that equal 0.97? Well, let's see. All right, guys, so we are going to take the square root of 2 plus the square root of 6, and this is all over 4. And notice what we get is 0.965, or the exact value of the sine of 105. So this identity is indeed true.